Hello everyone and welcome back to our videos. Today we will talk about the exhaust system. In both reciprocating and turbine engine, the purpose of the exhaust system is to remove the spent gases of combustion and safely route them overboard. To get the maximum efficiency from the engine, the exhaust system must function properly in addition, because a failure of this system could have disastrous results, such as fires or introducing toxic gases into cabin, and this result or this effect we talked about it on airframe book in chapter 14. Reciprocating engine exhaust system. Before we talk about the reciprocating engine exhaust system, we will have a reminder about the four strokes of reciprocating engine. As a quick reference, we will back to talk about the four strokes of reciprocating engine. And as we see in this figure, we have a piston, cylinder, connecting arm. Here we have two valves and we have ignition source, spark plug. In the induction stroke, at the top dead center, the inlet valve opens and the piston descends, creating a depression. This draws air and fuel mixture into the cylinder. Cylinder volume increases and the pressure decreases, and as the pressure decreases, the temperature also will decreases. After that, at the bottom dead center, as we see here, the inlet valve closes, trapping the mixture in the cylinder. After that, we have the second stroke and is called the compression. Both valves are now closed. The piston ascends and compresses the mixture of the combustion chamber. And here the pressure will increases, and as the pressure increases, the temperature also will increases and the cylinder volume will decreases. After that, we have the third stroke and it's called combustion. A spark plug ignites the mixture of fuel and air. After the mixture, piston is stationary at the top dead center. After that, on the power, as both valves remain closed, the increased gas pressure forces the piston down, and this is called the power stroke. After that, we have the number 4 or the fifth stroke, the exhaust stroke. And in this stroke, the exhaust valve is opened to the exhaust system, as we see now. As the exhaust gases passes from this area, it will goes to exhaust system. This exhaust system, we will talk about it today. A reciprocating engine produces high temperature and noxious gases as combustion takes place within the engine, and these exhaust gases are corrosive. Many modern exhaust systems are made up components using nickel chromium steel or other corrosion and heat resist. The advantages of the nickel chromium steel are corrosion and heat resist, low expansion coefficient, low weight, and the last one, provide long, trouble-free operation with minimum of maintenance. Types of exhaust system on reciprocating engine. There are two types of exhaust system in use in reciprocating engines, and they are short stack or open system, and the second one collector system. The short stack system is generally used on non-supercharger engines and low engine powered engines where noise level is not factor. We will start talk about the short stacks. Early in line and V engine often used straight stacks, which were simply short section of steel tubing welded to a flange and bolted to the cylinder exhaust port. So you have to focus here the short stacks used in the inline and the V-shape engine. The advantages of the short stack. They have many advantages, and the first one, effective at getting the exhaust out of the engine compartment. The second advantage is relatively simple and removal and installation. As the short stack has advantages, also it has disadvantages. The disadvantages of the short stack are no silencing capability, and when the aircraft was side-slipped, cold air could flow into these stacks and warp the exhaust valves. The second type is the collector system. The collector system you might encounter on an airplane include the opposite type engine, exhaust manifold, and radial engine collector ring. So you have to focus here also the collector system used on the opposite and the radial engine. The opposite type engine exhaust manifold. There are many types of collector system used on opposite engines. The first one, typical system, consists of risers from each cylinder and an exhaust collector on each side of the engine. The risers are attached to cylinder with brass or special lock nuts and are heat resistant. The second type of collector that used on opposite engine, on some system, a crossover tube connects the exhaust stacks on the left side of the engine with stacks on the right side. Sections of the exhaust system are usually joined together with a spring-loaded ball joint, and this the ball joint. When properly installed, the ball joints are loose enough to allow movement but tight enough to prevent leakage. Ball joints also compensate for slight misalignment of the parts. On the radial engine, we have a collector ring. The collector ring is graduated in size. The small section carries the exhaust from only 2 cylinders. The ring increases in the size. It nears the point where the tailpipe connects to the collector. This increase in size is necessary to accommodate the additional gases from the other cylinder.